Welcome to BookBuzz Reviews and Summaries. Picture this. You're standing on the edge of a cliff, the ocean roaring beneath you. You toss a pebble into the air. It rises, pauses, and plummets downward.
But why?
What invisible forces dictate the pebble's rise and fall? What if I told you that by the end of this discussion, you'll not only understand the science behind that pebble's journey, but also how those very forces shape the tides, the planets, and even the vast galaxies beyond our reach? That's the power of physics. It's not just a subject, it's the story of how everything works. Now, I know what you might be thinking. Physics can feel like a daunting maze of symbols and equations. For many of us, the word alone conjures memories of scribbling down formulas in high school or furrowing our brows at confusing diagrams in a textbook. But super simple physics changes the narrative. It transforms physics from something abstract and intimidating into something tangible, relatable, and, dare I say it, fun. With bite-sized lessons, vivid illustrations, and real-world applications, this book serves as a bridge, connecting complex concepts to everyday life. Let's pause for a moment and reflect on this. Did you know that every time you flip a light switch, send a text, or even take a step, you're engaging with the principles of physics? From the electric circuits powering your devices to the friction between your shoes and the ground, physics is constantly at play. It's the silent orchestrator behind the symphony of life. And yet it often goes unnoticed. But not anymore. With the help of this book, you'll start to see the world differently, as if a hidden layer of reality has been unveiled. One of the most brilliant aspects of super simple physics is its approachability. It takes the vast and sometimes overwhelming field of physics and breaks it down into manageable pieces. Imagine nibbling on small, delicious bites of knowledge rather than trying to swallow a feast all at once. Each chapter is like a well-crafted puzzle piece that, when assembled, gives you a clear picture of the physical world. Let's talk about gravity, for example. It's a force we all experience every day, yet its true nature remains one of the most mind-bending mysteries of the cosmos. Why does the Earth pull you down instead of pushing you away? How did Isaac Newton's simple observation of a falling apple lead to an understanding of planetary motion? And how did Einstein's revolutionary theory of general relativity take this understanding to an entirely new level? Don't worry, we'll unpack all of this in a way that's as straightforward as chatting with a friend over coffee. Or consider the concept of energy. It's the currency of the universe, fueling everything from the smallest particles to the largest stars. But what does it mean when we say energy can't be created or destroyed? How does energy flow and transform in your daily life, whether you're charging your phone, boiling water, or riding a bicycle? By the time we're done, you'll not only grasp these ideas but also appreciate how they connect to the broader tapestry of existence. What makes super simple physics particularly special is its focus on real-world applications. Have you ever wondered how airplanes stay in the air, how your car's engine works, or how GPS systems guide you with pinpoint accuracy? These aren't just magic tricks, they're feats of physics. This book peels back the curtain, showing you the elegant principles that make modern technology possible. But it's not just about technology. Physics also explains the wonders of nature. Why is the sky blue? What creates the breathtaking colors of a sunset? How do waves travel across the ocean? Every natural phenomenon, no matter how ordinary or extraordinary, has a story rooted in physics. And this book is here to help you uncover those stories, one fascinating detail at a time. Now, you might wonder, why should you care? Why invest your time in understanding physics? The answer is simple. Physics isn't just about knowledge. It's about perspective. It's about seeing the world with fresh eyes, with a deeper appreciation for the intricate dance of forces and interactions that make life possible. It's about empowering yourself with the tools to ask questions, seek answers, and embrace curiosity. And who knows? Perhaps this newfound perspective will inspire you to tackle challenges, innovate solutions, or simply marvel at the beauty of the universe. So, as we embark on this exploration of super simple physics, I invite you to set aside any lingering doubts or fears about the subject. Instead, approach it with a sense of wonder and openness. Remember, physics isn't about memorizing equations or acing exams. It's about understanding the world around you. And with this book as your guide, that understanding is closer than you think. As we continue, we'll delve into some of the most exciting chapters of this book, exploring topics like motion, forces, waves, electricity, magnetism, and the structure of the universe itself. Along the way, we'll highlight key takeaways, share practical examples, and bring abstract concepts to life. By the end, you'll walk away not just with knowledge, but with a sense of awe for the science that shapes our reality. Are you ready to unlock the secrets of the universe, one simple lesson at a time? Let's dive into the world of super simple physics and discover just how extraordinary our everyday existence truly is. Chapter 1: Motion, the Language of Movement. The book begins by asking a deceptively simple question: how do things move? Movement, the authors explain, is the heartbeat of physics. Motion is everywhere, from the steady orbit of planets to the fleeting swoosh of a soccer ball. Here, we're introduced to some of the most crucial concepts, including velocity, acceleration, and Newton's 3 laws of motion. But instead of sounding like a lecture, the book crafts a story around these ideas. For instance, Newton's first law, also called the law of inertia, is explained through an everyday scenario: a cup of coffee on your car's dashboard. If you suddenly slam the brakes, the coffee doesn't magically stay still, it spills forward.
Why?
Because the coffee's inertia keeps it moving forward, even when your car comes to a sudden halt. The chapter uses similar engaging anecdotes to explain the other laws. Newton's second law, force equals mass times acceleration, is illustrated through the example of pushing a shopping cart, an easy task when the cart is empty, but a workout when it's full of groceries. Newton's third law, for every action, there's an equal and opposite reaction, is brought to life with the dramatic imagery of a rocket launch. By the end of this chapter, readers aren't just memorizing formulas, they're imagining themselves as physicists deciphering the secret language of motion in the world around them. Chapter 2: Forces, the Invisible Push and Pull. Once you've understood motion, the book dives into the forces that drive it. Forces, as explained here, are the invisible puppeteers of movement. Gravity, friction, tension, each one has its unique personality and role in the grand story of physics. Gravity, for instance, is presented not as a dry concept, but as the relentless pull that keeps our feet on the ground and the moon in orbit. The authors weave in historical tales, like Galileo dropping spheres of different masses from the Leaning Tower of Pisa, to show how we came to understand gravity. Friction, on the other hand, is framed as both a friend and a foe. It's what allows us to walk without slipping, yet it's also the reason why your bike's brakes wear out over time. This dual nature of friction is illustrated through colorful examples, making it easy to see how this force impacts our daily lives. By the end of this chapter, forces no longer feel like abstract ideas. They're tangible, almost alive, shaping every movement and interaction in the universe. Chapter 3: Energy, the Currency of the Universe. The narrative then shifts to energy, described as the ultimate currency of the universe. Energy, we're told, cannot be created or destroyed, only transformed. This chapter is filled with metaphors that make even the most abstract concepts feel relatable. For instance, kinetic energy, the energy of motion, is compared to a speeding car, while potential energy, stored energy, is likened to a coiled spring, ready to burst into action. The authors also explore fascinating phenomena like the conservation of energy, showing how energy flows seamlessly between forms. One particularly captivating section discusses renewable and non-renewable energy sources. Readers are taken on a journey from the fiery heart of the sun to the depths of coal mines, gaining a deeper appreciation for the energy that powers our world. Chapter 4: Waves and Sound, the Invisible Travelers. Waves and sound are introduced as the unseen messengers of the physical world. Imagine dropping a pebble into a pond and watching the ripples spread outward. This is the essence of wave behavior. The authors explain the two main types of waves, transverse and longitudinal, using clear diagrams and engaging analogies. Sound waves, for example, are compared to a slinky toy. As you push and pull the slinky, compressions and rarefactions travel along its length, just like sound waves moving through the air. The chapter also explores fascinating topics like pitch and volume, showing how different wave frequencies create the symphony of sounds we hear every day. Chapter 5: Heat and Temperature. The dance of molecules, heat and temperature come to life as the invisible dance of molecules. The authors explain how heat flows from warmer to cooler objects, much like water pouring downhill. They also delve into the three modes of heat transfer: conduction, convection, and radiation, using vivid examples. Conduction is likened to a metal spoon heating up in a pot of soup. Convection is compared to the swirling currents of hot air rising in a room. Radiation is illustrated with the warmth of sunlight on your skin. By the end of this chapter, readers can visualize heat as a dynamic process, constantly flowing and transforming the world around us. Chapter 6: Electricity, the Spark of Life. Electricity is introduced as a concept that powers nearly every aspect of our modern lives. The authors take us back in time, recounting the story of Benjamin Franklin and his famous kite experiment. They use this tale to launch into the basics of electric charges, current, and circuits. Electricity, they explain, is the flow of tiny particles called electrons. Using the analogy of water flowing through a pipe, the book makes the idea of electric current instantly relatable. Voltage is likened to the pressure pushing the water, while resistance is compared to obstacles in the pipe, like debris slowing the flow. Readers are introduced to the two types of circuits: series circuits, where the current flows in one continuous loop; parallel circuits, where the current has multiple paths to follow. The authors also highlight the role of conductors and insulators. They describe conductors, like metals, as friendly hosts that let electrons move freely, while insulators, like rubber, act as barriers. These concepts are brought to life with real-world examples, like why power cords are coated in plastic or why birds can perch on power lines without harm. The chapter wraps up by discussing batteries and their ability to store and release energy. Readers leave with a newfound appreciation for the simple yet profound forces that light up our homes and power our devices. Chapter 7: Magnetism, the Invisible Force. The journey continues with magnetism, a force that feels almost magical in its invisibility. The authors dive into the fascinating connection between electricity and magnetism, explaining how they are two sides of the same coin. Magnetism is introduced through its most iconic symbol, the bar magnet. Readers learn about the North and South poles, the invisible magnetic field lines, and the simple rule that opposites attract. To illustrate these ideas, the book uses the classic example of iron filings aligning around a magnet, forming a visible representation of the magnetic field. One of the most exciting sections explores electromagnetism. Using engaging visuals and anecdotes, the authors explain how a current flowing through a wire creates a magnetic field. This principle is the foundation of electric motors, generators, and countless other technologies. The chapter also touches on Earth's magnetic field and its role in guiding compasses and shielding us from harmful solar radiation. By the end, magnetism is no longer an abstract concept, but a tangible force shaping the world around us. Chapter 8: Light, the Messenger of the Universe. Light takes center stage in this chapter, described as the ultimate messenger of the universe. The authors explain that light is both a wave and a particle, a duality that has fascinated scientists for centuries. Readers are introduced to the electromagnetic spectrum, a vast range of light waves from the long, lazy radio waves to the high-energy gamma rays. Visible light, the tiny sliver we can see, is explored in detail, with explanations of how it splits into the rainbow colors of red, orange, yellow, green, blue, indigo, and violet. The book doesn't just stick to the science, it also taps into the wonder of light. Imagine the journey of a photon traveling from the surface of the sun to Earth, taking over 8 minutes to reach us and bring warmth and energy. The chapter also explores fascinating phenomena like reflection, refraction, and diffraction. Through vivid examples, like why a straw appears bent in a glass of water or how rainbows form, the authors make these concepts easy to grasp and endlessly fascinating. Finally, readers learn about the speed of light, one of the most mind-boggling constants in the universe. Light travels at a staggering 299,792 kilometers per second, a speed so immense that it forms the basis of Einstein's theory of relativity. Chapter 9. Atoms and Matter, the Building Blocks of Everything. This chapter zooms in on the microscopic world, exploring atoms, the tiny building blocks of all matter. The authors take readers on a historical journey from the ancient Greek philosopher Democritus, who first imagined atoms, to modern discoveries about subatomic particles. Atoms are described as having three main parts: protons, positive charge; neutrons, neutral; electrons, negative charge. Using relatable analogies, the book compares an atom to a miniature solar system, with electrons orbiting a dense nucleus of protons and neutrons. The authors also highlight how different arrangements of these particles create the vast diversity of elements on the periodic table. The chapter introduces isotopes, ions, and the basics of chemical bonding, showing how atoms combine to form molecules. One particularly engaging section explains the states of matter: solid, liquid, gas, and plasma, and how the arrangement of atoms changes in each state. Readers are left with a profound sense of awe at the complexity and beauty of the microscopic world that makes up everything we see, touch, and experience. Chapter 10. Energy, the Power to Do Everything. Energy, often called the currency of the universe, is the centerpiece of this chapter. The authors begin by breaking down energy into two main categories. 1. Kinetic energy, the energy of motion. 2. Potential energy, stored energy, waiting to be released. Through relatable analogies and colorful illustrations, energy transformations are explained. For instance, a roller coaster climbing a hill has maximum potential energy at the top and maximum kinetic energy as it hurtles downward. The chapter delves into the law of conservation of energy, one of physics' most profound principles. Energy, they explain, cannot be created or destroyed. It only changes form. To demonstrate this, the book uses examples like a pendulum swinging back and forth, converting kinetic energy to potential energy and back again. Readers are also introduced to renewable and non-renewable energy sources. The authors discuss solar, wind, and hydroelectric power while addressing the challenges of fossil fuels. These real-world connections make the concept of energy feel relevant and urgent, highlighting its role in powering our homes, cities, and future innovations. Chapter 11. Motion. Understanding how things move. Motion, the heart of physics, takes center stage in this chapter. The authors bring Sir Isaac Newton into the spotlight, recounting the famous story of the falling apple and how it led to his groundbreaking laws of motion. Newton's 3 laws are presented in simple, relatable terms. 1. First law: inertia, objects at rest stay at rest, and objects in motion stay in motion unless acted upon by a force. Picture a soccer ball sitting still until someone kicks it. 2. Second law: force equals mass times acceleration. The harder you push an object, the faster it moves, depending on its mass. Imagine trying to push a car versus a shopping cart. 3. Third law: action and reaction. Every action has an equal and opposite reaction. This explains why a balloon flies away when you let it go. The chapter also explores the concepts of speed, velocity, and acceleration, tying them to everyday experiences like driving a car or riding a bicycle. To make the laws of motion even more tangible, the book introduces gravity as the force that keeps our feet on the ground and the planets in orbit. By weaving in engaging examples and simple experiments readers can try, the authors ensure these principles are easy to grasp and fascinating to explore. Chapter 12: Waves, the Rhythm of the Universe. Waves, the unseen rhythms that permeate our world, are explored in this chapter. The authors begin by explaining the two main types of waves: mechanical waves, like sound and water waves, which need a medium to travel through; electromagnetic waves, like light and radio waves, which can travel through the vacuum of space. Through vivid illustrations, the book demonstrates key properties of waves, including amplitude, wavelength, and frequency. For instance, the height of a wave is likened to the volume of a song, while the frequency relates to the pitch. The chapter dives into sound waves, explaining how vibrations create the sounds we hear. The authors use examples like musical instruments and echoing caves to show how sound waves behave in different environments. Light waves are revisited, but this time with an emphasis on how they interact with matter. Readers learn about phenomena like absorption, transmission, and scattering, which explain why the sky is blue and sunsets are red. The authors also introduce seismic waves, the ripples created by earthquakes, showcasing how waves can reveal secrets about Earth's interior. These real-world applications highlight the importance of understanding wave behavior in science and technology. Chapter 13: Space and the Universe, Exploring the Final Frontier. The final chapter takes readers on a cosmic adventure, exploring the vastness of space and the mysteries of the universe. It begins by revisiting gravity, explaining how this force shapes the motion of planets, stars, and galaxies. The authors delve into the solar system, providing a tour of the planets, moons, and other celestial objects. They discuss the sun as a massive nuclear reactor, converting hydrogen into helium and emitting energy that sustains life on Earth. Next, the book expands its scope to stars and galaxies. Readers learn about the life cycle of stars, from their birth in nebulae to their dramatic deaths as supernovae. The authors describe black holes, the enigmatic remnants of massive stars, as regions where gravity is so strong that not even light can escape. The chapter also touches on the Big Bang Theory, the leading explanation for the origin of the universe. Through simple language and engaging visuals, the authors describe how the universe has been expanding ever since its explosive beginning nearly 14 billion years ago. Finally, readers are introduced to the tools of modern astronomy, like telescopes and space probes, that allow scientists to explore the cosmos. The chapter ends with a message of wonder and curiosity, encouraging readers to look up at the night sky and ponder the mysteries yet to be uncovered. As you close the final page of Super Simple Physics, the ultimate Bitesize study guide, you're left with more than just facts and formulas. You're left with a new lens through which to view the universe. In this engaging and visually stunning guide, DK Publishing has turned one of the most complex subjects into something clear, digestible, and surprisingly exciting. The beauty of this book lies in its simplicity. With every concept broken down into its essential parts, it strips away the intimidation that often comes with studying physics. Whether exploring Newton's laws, the mysteries of quantum mechanics, or the intricacies of thermodynamics, the book's bite-sized format allows readers to absorb information effortlessly, making it a perfect companion for students, curious minds, and lifelong learners alike. But Super Simple Physics is more than just a study guide. It's an invitation to marvel at the wonders of science. By connecting theory to real-world applications, it transforms abstract equations into tangible truths that shape our everyday lives. You're not just learning about the speed of light or the laws of energy conservation. You're understanding the principles behind the technologies you use, the natural phenomena you observe, and the very fabric of existence itself. What sets this book apart is its ability to inspire. The clarity of its explanations, combined with vivid visuals and practical examples, ignites curiosity and a genuine desire to explore further. It reminds readers that physics is not reserved for scientists in labs. It's a universal language that anyone can learn to speak, regardless of background or expertise. As you walk away from super simple physics, you carry with you not only a solid foundation of scientific knowledge, but also a newfound appreciation for the elegance of the physical world. Physics is no longer a daunting subject confined to textbooks and classrooms. It's a tool for understanding how the universe works, a gateway to asking bigger questions, and a stepping stone to discovering even more about the world around us. In the end, this guide is a testament to the idea that learning doesn't have to be overwhelming or dull. Through its intuitive structure and engaging content, DK Publishing proves that even the most challenging topics can be approachable, relatable, and fun. So, whether you're preparing for exams, brushing up on forgotten concepts, or simply curious about how things work, Super Simple Physics provides all the tools you need to succeed and the inspiration to keep exploring. This book is more than a guide to physics. It's a celebration of curiosity, learning, and the power of simplicity. And as DK Publishing shows us, when we simplify the complex, we don't just make it easier to understand. We make it infinitely more exciting to explore. Thanks for listening. Please like, subscribe, and click the bell icon to get new video updates. Happy learning!